Okay, let's continue on solving problems from the GMAT Official Guide 12th edition. This is the third video in the series, and we are on question number 10 on page 273. Question number 10. Water is pumped into a partially filled tank at a constant rate through an inlet pipe. At the same time, water is pumped out of the tank at a constant rate through an outlet pipe. At what rate in gallons per minute is the amount of water in the tank increasing? So that sounds complicated, but what we have is a tank, and we have water going in at some rate and water going out at some other rate. And they're asking at what rate in gallons per minute is the amount of water in the tank increasing? So presumably the rate going in is greater than the rate going out. So let's evaluate the statements. Statement 1 says the amount of water initially in the tank is 200 gallons. Well, by itself, that doesn't tell us anything about the rate of increase of the water in the tank, so that's going to be insufficient. And we'll be down to answer choices B, C, or E. Statement 2, and we're going to forget that we know statement 1 when we evaluate statement 2. Statement 2 is water is pumped into the tank at a rate of 10 gallons per minute, so the rate is going to be 10 gallons per minute going in, and out of the tank at a rate of 10 gallons every 2.5 minutes. So you could reduce that outlet rate to gallons per minute, 10 gallons for every 2.5 minutes, but actually you don't have to do that calculation. Basically, statement 2 is going to give us a rate going in, and it's going to give us a rate going out. And then we'll be able to answer the question, at what rate in gallons per minute is the amount of water increasing? So this is a question that you don't have to solve, and the correct answer choice is going to be B for question number 10. Let's move on to question number 11. Is x a negative number? In other words, is x less than 0? Statement 1. 9x is greater than 10x. Let me rewrite this here. 9x is greater than 10x. Well, this is a case where we simply have to plug in some numbers and see what this tells us about the possible values for x. Basically, I would make a table with possible values for x, then 9x, and 10x. And if you plug in a value like 1 for x, 9x is going to be 9, and 10x is going to be 10. So 1 is not a permissible value for x because 9x is not greater than 10x. And I can see that's going to be true for any positive value of x. That's also going to be true for 0. We cannot plug in 0 for x. And what it looks like is we can only plug in negative numbers. If you plug in negative 1 for x, then 9x is going to be negative 9, and 10x is going to be negative 10, and 9x is greater than 10x. So statement 1 tells us that, yes, x is a negative number, x is less than 0, and it's going to be sufficient. We'll be down to answer choices A or D. Statement 2 tells us that x plus 3 is positive, or x plus 3 is greater than 0. If we solve this, we get x is greater than negative 3. And actually, just looking at this, x could be negative 2 or negative 1, but it could also be positive values like 1, 2, or 3. So when we ask the question, is x less than 0, statement 2 gives us sometimes it is less than 0, sometimes it's not less than 0. So statement 2 is going to be insufficient, clearly, and the correct answer is going to be A. Okay, let's move on to question number 12. If I and j are integers, is I plus j an even integer? Well, that's going to be true when both I and j are even or both I and j are odd numbers. It won't be true if I is even and j is odd, because that addition would result in an odd number. So we're looking to prove that I and j are both even numbers or both odd numbers. So statement 1 tells us that I is less than 10. Basically by itself, that's not going to really tell us anything. All it tells us is that I is less than 10. It doesn't tell us anything about the sum of I plus j. Then statement 2, which we're evaluating independently, is I is equal to j. Well, this is going to work because this tells us that we have either two even numbers or two odd numbers. Or they could both be equal to 0, and 0 is considered to be even. So the sum of I plus j must be even. So statement 2 is going to be sufficient, and the correct answer choice is B.